One of the great things about being a nerd in today's society is that we have all of these wonderful graphical user interfaces. I've got Windows in my Windows desktop, I've got beautiful Mac OS screens, even Linux with their desktops are absolutely amazing. I just take my mouse and click on stuff and I can open programs and delete files and format hard drives and do all kinds of stuff. However, my friends, deep inside every operating system on Earth is an alternative way to get your computer to do stuff called the command line interface. The command line interfaces conceptually are very old, but they've been kept as up to date as any GUI, and if you're a real nerd and you want to get real work done, you will work at the command line interface. Excited? You want to see one? Hey, I've got a Windows system right here. Let's take a look. So just type CMD, and you'll see this thing called command prompt comes up. And ta-da, my friends, you are looking at a command line interface. Now, when it comes to command line interfaces, this is just one choice. You can have lots of different command line interfaces. These different alternatives are known as shells. Let me show you another one in Windows. So now I have an alternative command line interface, a different shell called PowerShell. Now if you look at these at first you go, well, one's blue and one's black, but what's the difference? There are huge differences which we're going to be discussing throughout the episodes in this particular chapter, so brace for impact. Now keep in mind, there are shells all over the place. For example, if I've got a Linux system, I've got a totally different shell there. Give me a second, I'll bring up a Linux system right here and show you yet another shell. Here I am in Ubuntu Linux, and I'm going to fire up this thing called a shell. Look at me double clicking like a Windows guy. Now if you take a look here, this looks a little different from those shells we saw in Windows, but this is what we call a bash shell in the Linux world. It doesn't stop here. Macs have these as well. You want to take a look at a Mac shell? I've got one right here. Let's take a peek. There are all kinds of different shells out there, but the interesting thing is that they store a lot of common functions. So what I want to do right now is I'm going to head back into Windows and we're going to work with the Windows command shell just to get an idea of the look and feel of how these shells work. Now before we get in here, I need to warn you about one thing. You are about to learn some really powerful commands. And these are commands that could literally wipe your hard drive, that could just wreak havoc. So one of the things that pretty much all shells have in common is the concept that you can only do certain commands as the super user, administrator, whatever you want to call it. Now, different operating systems have different ways to protect you. Let's watch the Windows way as I load that command shell. So I'm going to type CMD again, but this time I'm not just going to click on it. I'm going to right click, and this time I'm going to say Run as Administrator. By doing this, I can now run any of these literally thousands of very powerful commands right now. So if you're in a command shell, you need to be careful about what you're doing, and well, that's what all these episodes are all about. All right, let's get in here and let's do some CLI. You ready? Okay, me too. All right, first of all, I'm going to just type a command. Now this command I want to show you right now is called dir. So I type dir and I hit enter. Holy shamolians, look at all this stuff. So what we're looking at here, I'm going to scroll up a little bit, is the date and time that these files were created, how big they are in bytes, the name of the file, and you see this right here where it says dir? That's not a file, that's a folder. Back in the old days, we never called anything folders. We called them all directories. The term directory and folder are exactly the same, and I'm going to interchange them like crazy, so you be ready for that, all right? Back to our dir command. Now, you can see that I can scroll up and down, but if anything's changed, I'm going to have to type the command again. So let's type the dir command again, except this time I'm going to put something on the end. Do you see that? That's a little /p. Anything you put on the end of a command in a command line is known as a switch. There's zillions of switches for zillions of different commands. If it's on the end, it's a switch. So this time, what it's going to do is it's going to show me all this stuff one page at a time. Now this little dir command is pretty indicative of the gazillions of commands we use at a command line. None of them are really plain English, and you have to learn this stuff, and this series is the best place to get started. So if you learn about something, well, how do you remind yourself? Like, what did that switch mic use to show one page at a time when he typed dir? Well, let me show you a really important switch in the Windows world. Ready? You see that slash question mark? What that's going to do, it's going to say, teach me a little bit about the dir command. So it will go through and it will show you, look at all these different switches I can use. So it's very, very helpful to be able to remember that slash question mark. Now equally you can do something like this. Just type in help and then the command you're interested in, and you basically get the exact same output. For the exam, make sure that you remember that slash question mark switch and then help and then the name of the command. Nobody has these things completely memorized. I've been working on this particular type of command line now for, okay, a long time, and I still have to go into help all the time. It's normal and it's okay. All right, so let's go ahead and type CLS and get our screen cleared. Now, if you take a look up here, you'll see it says C:\Windows\System32. So this prompt actually points at a particular location. The prompt itself is looking in a very specific folder. And as we look in different folders, this will actually change. So these are the basics of a command line using Windows. Let's do it again, except this time I want to do it in Linux. You're going to see it's basically the same with a few little changes. So here in Linux, I'm running this little, what they call a bash shell, B-A-S-H. Now, a couple of things that take place. Number one, you can't open shells as an administrator like we do in Windows. Instead, what we do is we use the command sudo. So if I want to do anything, I'm going to type sudo and then whatever command I want. So the Linux equivalent of dir is ls. And I'm going to have to type in my password again, and then it works. So be comfortable with this difference. Remember, in Windows, you're going to start up a shell as an administrator and then you can do anything you want. In Linux, you just start up a shell and then anytime you do a command that you're worried about, just type sudo at the front. I didn't have to type sudo with that ls command. It would run with anybody, but that's basically the nomenclature. By the way, if you want to, you can open up a command shell in Linux and then just type su, hit enter, and then type in a username and password for a super user, and you don't have to type sudo anymore. However, the Linux powers think that's a really bad idea. We all believe in the power of sudo, and I think it's a good idea too. Anyway, back to the terminal. So as we take a look at this, we'll type ls by itself because we don't have to type sudo. And you'll see we've got, in this particular shell, it marks folders in blue and files in white. And that's just the way this one's set up by default. In fact, if you want to, you can change it. If you want to clear the screen, type CLEAR, don't type CLS, and that'll clear the screen for you. So the whole idea of switches also comes into play in a Linux environment. Let's go ahead and type that ls command, except this time I'm going to put a little change on it. So now I'm going to type ls, but in this case I'm going to type ls minus L. So I've put this little switch on here. And what this does is it shows me a little bit more information. So it shows me all of the file and folder permissions for each one of these. It shows us who the actual owner and who the group is. It shows the size and then the date and time as well as the name. Switches are just as important in the Linux world as they are in the Windows world, so be comfortable with it. Now you notice that when I typed a switch here, I used a dash and not a slash. There is no guarantee. Even in the Windows world, sometimes switches use a dash, although I can't say I've ever seen a slash used in the Linux world, so don't count on that one. All right, now the big challenge we have is that how do we use these tools? Is there a slash question mark? No, but there's something very, very close, and it's called look at the manual. Let me show you. If you want information on how to use a command, just type man and then the name of the command you're interested in. So this will bring up the manual for this particular command. So it shows you all of these little switches that we can put in with the ls command. and Q to quit, I believe it says. There we go. And we're right back into our shell. The last thing I want to mention is, okay, I've been working in a shell. How do I turn it off? Well, you can usually type something like exit or quit, but on all operating systems, just close the window and you'll be absolutely fine. Okay, these are just some of the basic concepts of how these different command line interfaces work. Keep in mind, we've got lots of shell options out there, and we go through other episodes. Remember, there's always help somewhere. If you're going to be working at a command prompt, well, you better get comfortable navigating around your system. So in this episode, what I want to do is just show you how to move around your computer, and let's go ahead and start with Windows. The first thing I want you to notice, when I started this command prompt, I did not start this with administrator privileges. So it puts me in what we call our home directory. I'm logged in as Michael M. Now, if I do a dir in here, you're going to see all of these different folders. There's my desktop, my documents, my downloads. This is all my stuff. Every operating system has some kind of home directory where individual users go to. We like to keep users in their home directory because we can go a lot deeper than this, and we're about to, and that's where some of the scary stuff be. There be dragons. So let's go ahead and take a look at some dragons here in Windows. The first command I'm going to teach you is cd \, just like that. Now, what's happened here, you can see the prompt has changed. We're no longer in the users/Michael M folder. We're now in what's known as the root directory. So if I type a dir in here, you're going to be seeing the core files for the operating system. So here's the program files 86. Here's actually the users. Here's Windows. This is all the absolute critical files. You want to take this system out, just delete that Windows folder right there. It's not that easy, but you could. So that cd command is really important. cd stands for change directory. So if you take a look, I've typed dir. I just type it again, and you can see I've got a bunch of directories in here. See, here's a directory called Timmy. If I want to go into that directory, I just type in cd, and you, in fact, if you want to, you don't even have to put a space in there. cd/Timmy. I hit enter, and you'll now see that I'm in the Timmy folder. The actual prompt shows that, and if I type dir, we should see something different, and this is basically an empty folder. So if you take a look here, what you'll see is dot and double dot. Dot basically says where I am right now. This is me. And double dot is the breadcrumbs that this folder connects to the next folder upstream. We can actually use these to our advantage. Let me show you. So we can see I'm in the Timmy folder. To go up one in the folder chain, all I have to do is type cd space dot dot. Now Timmy is connected to the root directory, and we can use this as a shortcut to go up and down. Now let's play with this a little bit more. I see another folder up there called Windows. Here, I'll do dir again in case you don't believe me. So here's a folder called Windows. So I can type cd/Windows, and I can get into the Windows folder. Now if I type dir here, there'll be a lot in here, but there'll be a few. You'll see there's a lot of folders in here. So here's one folder called temp. Now for me to get into that, if I ever want to go down into the chain a little bit, you don't use a slash at all. You just type cd space and then the name of the folder. And that'll get you in there. There's a lot of rule sets in here that are really shortcuts that I'm showing you. Let me show you cd command with the longhand. Not that anybody does this, but it'll help clarify a couple of the commands we just did. So right now, if you look at this prompt, it says c:\windows\temp. If I want to get to c:\windows, the official format is to type cd space and then what the prompt would look like if I was there. Now, we don't type in that greater than sign or a flashing cursor, but I'm going to type cd space c:\windows. . Now, because we know that there's a shortcut using the, let me get back into temp. Now, because we know there's a shortcut using the double dot, we can cheat and go, and that brings us up one. In fact, if we want to, we can go all the way to here, and we're back at the root directory. So let's march through this again one more time. So this time, I see there's a folder called users. So I'm going to cd. Now, if I was doing it the official right way, I would type cd space c:\users. Whoops. Now, there's a couple more little cheats we can do here. So let me get back to the root directory. I'm going to type cd. Because I'm already in the C drive, I don't have to type c:. So I can type cd/users, and that'll get me up one. And let's take a look what's in here. We see there's a folder called Michael M. So watch this. I'm going to go back to the root directory, and in one jump, I'm going to go all the way to users Michael M. So with the official criteria, I type cd space, well, in fact, let's skip the c:, because we already know we don't have to do that. So I'm going to type in users, and I'm going to type in Michael M. And Viola, I get there in one big shot. So the trick to the cd command is remember that you can do a lot of shortcuts. Officially, you're supposed to type cd space and whatever the path is you want to go to. And that works. There's no problem with that. But we can use shortcuts, for example, dumping the c:, using a space just to go down one in the tree, using your double dots to go up one in a tree, and the big one is that cd / will always get you back to the root directory. The first few times you play with this, you're going to get lost, and that's okay. Just type cd /, you'll be at the root directory and start cding your way around a little bit. And remember, anytime you change directory, type dir, because you want to see the contents of where you now are. So this is great for marching around in the same drive. But we have other drives on this computer. For example, I've got a D drive. If we want to get to another drive letter, just type the drive letter. So to get to the D drive, I just type D:. I can type dir in here. There's not very much in there, but I'm now on the D drive. Be careful with this. People will start saying, oh, I have to cd over to the D drive. No, 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 no. Get to the drive letter you want to be on, and then use your cd commands to get to the folder that you want. So watch this. This could be interesting. When I typed D:, I was already in the c:\users \Michael M. It's still up on the screen. You see that? Now if I type c: to get back to the C drive, look where it puts me. So it's always going to put you back in the folder you were in when you originally left that particular drive letter. So just be careful with that. Everybody thinks it's always going to get dumped in the root directory like it's some kind of hallway with a front door. No, whatever directory you left from, you're going to go back to. Now, also keep in mind is that I've got a lot of drive letters here. Watch this if I type one like X:. It just says the system cannot find the drive specified. It's nice when you're in a graphical user environment and you're running things like File Explorer in Windows because you can see all the different drives. When you're at a command prompt, sometimes you don't keep track of all the drive letters, and it's very common just to type in something. It's not going to hurt anything at all. It just says there's nowhere to go there, so you're like, oh, okay, good enough. Now, I want to do all this over again, except this time, let's do it in Linux. There's a couple of things that's very different in Linux. In particular, Linux doesn't use drive letters. Unix has a root directory, but it's just a /, and everything, including extra drives and CDs, they just get folders mounted to this great /. So let's go ahead and do this again in Linux, but remember, we don't have drive letters this time. We just mount all these volumes as folders. So here I am back in Linux. Now the first thing I want you to notice, I've already got a CD-ROM mounted on here, which we're going to go over to and take a look at in a moment. But first, let's do some basic navigation. First of all, in Linux, and also Macs, by the way, because Linux and Macs are virtually identical in this part, we still use the cd command. However, things change a little bit. So let me do an ls so we can see what's in here. And we can see in blue that I have a number of folders. So in order for me to get to, for example, I see desktop there, I'm going to type cd, and folks, Linux cares about capitalization, so we have to match the capitalization exactly. So capital D, E, S, K. Now let me show you another fun little trick. This works in Windows too, by the way. If I hit Tab, you'll see that the only thing in here that starts with DESK is that desktop, right? Well, there's examples.desktop, but that starts with examples. If I hit Tab, it automatically fills it in. Now, the other thing I want you to take a look at is look at the slash. We're in a Windows environment, we use a backslash. In the Unix, Linux environment, we use a forward slash. And we just hit enter. Let me do an ls. I don't have much in there, so it's kind of blank. But we still use the cd command, but things change a little bit. So I'm going to show you a really handy command. What I want you to do is type cd space and then a tilde. This will always put you back into your home directory. So do an ls, and there it is. See, I told you, Linux and Mac, they have home directories just like anybody else. However, the root directory looks a lot different in this world. Let me show you. So we type cd space /, and that puts you in the root directory. Now, it's really hard to tell because the prompt in Linux, or at least by default in the bash shell of Linux, doesn't really change much. But if you look really closely there, you see that tilde? That tilde says we were in the home directory when we typed this, and now it just says a little slash. So if you actually ever want to see where you are in Linux, just type pwd. pwd just shows you what directory you're in. And you can see it's just a slash. That's because we're in the root directory. If we type ls, you are looking at the critical system files of the Linux system itself. So generally, it's a good idea to stay out of these core files unless you have a specific reason to be there. And regular users should pretty much never be in here. They should be staying in their home directories. Now, let's take a look at this screen one more time. And you can see I've got this CD-ROM mounted. Now, it's nice in the GUI, but I want to show you where it is in the Linux environment. So this is going to take a couple of clicks for us to get here, and we can practice with the cd command as we go. So first of all, as we take a look on this absolute root, what we're looking for is a folder called home. Ah, there it is right there. So I'm going to use my cd command. In this case, going down one, it works just like in Windows. Do an ls so we can see there's not much in here. Be careful. Linux distributions do all of this stuff differently. So you see home and you're like, oh, we're in Mike's home directory. Now, in this particular version of Linux, Ubuntu, this is a separate thing that allows different kinds of media to show up differently is what it boils down to. Do cd ... works the same. So I'm going to cd into media. So cd space media. Let me do an ls in here. And now we're looking at all of the different volumes and everything for Mike. So now I'm going to go into Mike. And let's do another ls. And if you take a look right now, you can now see, you see the name, let me clear this. So CCCOMA, CCCOMA, do you see that? So I can actually, if I want to, look at the contents. Thank goodness for tab, that's a lot of typing. Why don't we cd into that fella? There we go. And if we do an ls, that's the actual files that we see in the optical media. In fact, if I open up right here, you can compare these. So we see auto run, there's auto run, boot, boot, boot MGR, boot MGR, it's the same files. So navigation is a critical part of moving around our systems when you're at a command line. Keep in mind that a lot of these commands, especially between Windows, Mac, and Linux, are very, very similar, and that cd is a great example. The big difference is in the Windows world, we do a backslash, and in the Unix, Linux world, we do a forward slash. We work with folders at the command line all the time. Now, in other episodes, we've been navigating around folders, and that's fantastic. But there are situations where you're actually going to have to be creating folders or even deleting folders from a command line. There are literally thousands of reasons to do this. You're building up a bunch of driver's disks that you're going to be keeping on a thumb drive, or you've got a bunch of ISOs that you're pulling in from a script and you're doing it all from a command line and you don't want them laying all over your computer. So you need to not only, we're going to be doing this by hand in here where we're typing commands, but keep in mind in other episodes, all of this stuff you're learning for everything in the command line can be integrated into scripts, and that's where the beauty really kicks in for command line. So you got to learn how to make directories, make folders, and delete them from a command line. Let's do it. All right, so here I am at a D drive, and let me type dir, and you can see right now all it has is 3 folders in it. So what I want to do is make a folder, and I'm going to call this folder Mike. So to make something, you want to be in the folder above it, and this is exactly where I want it. So to make it, you just type md, make directory, and then the name that you want it to be. So I'm going to type in md space Mike, I hit enter, nothing happens. Remember, at a command line, if nothing happens, that's usually a good thing. People start doing these commands for the first time when they learn this stuff, and they do something right, they're expecting a $5 bill to come sliding out of the computer. Doesn't work that way. When you make a mistake, it will slap you in the head, but when you do something right, you often get nothing at all. So to see the results of this, I got to type dir, I got to see it. And there is Mike right there. Now while we're in here, this is a good opportunity to talk about capitalization. Windows doesn't really care about capitalization and Linux does. Now I've got a directory in here called Mike already. What I want to do now is I'm going to make another directory called capital M-I-K-E. Let's watch. So dir one more time. We see that Mike is there, right? Let me clear the screen. So I'm going to do md capital M-I-K-E. Ready? Windows does not look at capitalization. So when you're working in a Windows environment, keep in mind that you're only going to have one Mike directory. In Linux, I could have a capital M-I-K-E, a lowercase m-I-K-E. I could just make a capital I in Mike. So, but in Windows it doesn't matter. Oh, by the way, did you notice something? You just got an error. An error popped up on the screen. Oh, I got an error. No, you didn't. You got good information. Yeah, you made a mistake, but that's the beauty of a command line. You see a mistake, you're like, nothing blew up. I don't see any smoke. We're in good shape. I love errors because they let me know when I've got a little problem. All right, so let's clear this one more time. Let me do a dir to make sure we're all together. There's Mike. In fact, if you want to make sure it works, look, we'll just jump right into the Mike folder, cd Mike. There it is. I type dir. I'm inside the Mike folder. Now, if I want to, I could make a folder in a folder if I want. So make a directory, Mike again. There's nothing wrong with having multiple Mike folders. They just can't all be in the same folder together. So yeah, I can have a folder called Mike with a subfolder called Mike, no problem. I just can't have 2 in the same folder. Got the idea? All right. Now, I'm going to go ahead, and now what I want to do is delete a folder. So if I'll type dir one more time, there's the Mike subfolder in the Mike folder. So to get rid of it, all I have to do is type rd, and then the name of the folder I want to delete. Type dir, and it's gone. So let me get back up to the root directory of the D drive. So I've got these 4 folders in here. So let me go ahead and delete the top Mike folder, and it's gone. Fantastic. Now, watch this. Do you see that folder called VMS? And by the way, this is all the virtual machines I use in this course. Let's just go ahead and wipe them all out. You ready? Aha! Oh, look, another error. No, it's not an error. It's good information. You can't delete directories that have anything in them. So that's kind of a nice thing, and we take advantage of that particular feature. Sounds like fun? Great. Let's do it again in Linux. So now that I'm in Linux, let me do a quick ls. Show you that I'm sitting here in my home directory. Everything's fantastic here. So to make a directory, all I have to do is type in mkdir. Now to make this more interesting, I'm going to go ahead and cd into my desktop. And by doing that, we'll see it graphically appear as soon as I make it. So let's go ahead and make something called Mike. Ta-da, you've just made a folder. Now because it's Linux, oh, and by the way, I'm about to hit the up arrow key. This is convenient, huh? We call that history. And I'm going to make a directory this time with a capital M. Ah, see, Linux knows capitalization. Don't try this in a Windows environment. It will never work. Now, to get rid of a directory, we just type in rmdir. So to get rid of capital Mike, I'm going to type rmdir. I'm going to type capital M. I hit that tab key because it's the only folder in here that starts with a capital M. And it's gone. We're on a roll. I'm going to hit my up arrow key, change that capital M to a lowercase m, and I've deleted the folders. This seems pretty simple, but when we get into scripting and things like this where we need to start making directories within our scripts, you are going to love what you just learned in this episode. We are continually working with files from a command prompt. Anything from like moving big piles of videos to dealing with log files or all kinds of stuff like that. We're constantly in a world where we are copying files, we're moving files, we're deleting files. And in this episode, I want to show you how to do some of that. On top of that, I'm throwing in one little extra, but I'll save that till we get to Linux. Okay, so what I want to do right now is talk about deleting files. So if we take a look on my Windows system, we'll see when I type dir is that I've got a bunch of files here. So to delete a file, all you got to do is type del. By the way, erase also works, but del is what everybody uses. And then you type in the name of the file. I'm going to delete that Mic1 JPEG. You hit enter, and it's gone. See? No more Mic1 JPEG. There's a Mic2 JPEG. Don't confuse them. Okay? Isn't that easy? Yeah, well it is. So, number one, you'll notice that it didn't say anything. We just said delete, and it said, okay. There wasn't like, are you sure? Do you want to check? This is not going into a recycle bin. I mean, it's gone. So you need to be very, very careful when you're deleting from a command prompt. Now, the challenge we run into is that it would take forever to delete all these files individually. So instead, we use a wildcard. So let me show you how wildcards work. In this particular case, I want to delete all the files that have the extension txt. So I'm going to type del, but this time I'm going to type in an asterisk. Asterisks mean I don't care. And I'm going to type .txt. So let's look at what we just typed. Delete, I don't care what the first name is, dot, as long as the last name, the extension is txt. So I hit enter. And let's type dir to see the results of our work. Ta-da! All those files are gone. Now, the only other thing I want to show you with delete is the biggest wild card of all, and that is star.star, asterisk.asterisk, splat.splat. It's got a million names, but it works the same way. Now, granted, I've only got a couple of files in here, but it'll still work. So this time I'm going to type del, asterisk, period, asterisk, star.star, splat.splat. Now remember, it didn't give us an are you sure, right? This is the one time it will. And we hit Y for yes, type dir, and absolutely everything is gone. There's actually more wildcards to the Windows environment than just the asterisk, but the asterisk is the big one and the one you're going to see on the exam, so be comfortable with it. All right, so all we've done up to this point is delete. What I want to do now is let me grab those files, bring them back, and this time let's do some copying. Okie dokie, let's take a look. And now all my files are back, and now I've got to do something with them. Let's pretend for a moment that these are really critical files, and what I want to do is put them on a thumb drive as a quick backup. Now again, in a GUI environment, yes, we could drag them over, but this is going to be part of a complicated script file that's cleaning up all this stuff after I do a bunch of other things. So we want to make this run from a command line. So what we're going to do is copy. Now, copying is pretty straightforward, but you have to remember Mike's super duper fancy 5-step how to copy process. So let's make sure we know what we're going to do here. I want to copy all of those files over to my thumb drive. And my thumb drive is actually the K drive on this particular system. So I just want to copy them over to that thumb drive. So here we go. You ready? Mike's 5-step process. Number 1, get to the directory where the files you want to copy are located. So I'm there. I'm here in the D drive. This is where the files are. So step 1's done. Step 2, type the word copy in a space. That one's pretty easy. Step 3, type the name of the file you want to copy and a space. In this case, I just want to copy one file. Number 4, type the path of where you want it to go to. In this case, I'm just dumping them on my K drive. I don't have any folders on my K drive, but if I did have a folder like called Fred, I could do this. But in this case, there's no folders on my K drive. I'm just going to type it like this. That's step 4. And then number 5, hit enter. One file's copied. So whenever you copy, the first thing you want to do is go over to the destination to make sure it got there. And there he is. Fantastic. Let me delete that real quick. And go back to the D drive. Let me clear this mess up. So that's a basic copy. Now there's also a move command. The only difference between a move command and the copy command is instead of typing COPY, you type MOVE. The only actual functional difference is the copy makes a copy, move deletes the original after it's got it copied over. So make sure you're comfortable with both of those. The actual nomenclature is exactly the same. I don't want to run through a move. Once you see copy, move will make sense. Now let's go ahead and take a look one more time. I got all these files. Now this time I want to copy all of the JPEGs over to the K drive. So I'm in the right directory. I type copy in a space. I type the file name, except this time I'm going to use a wildcard and a space. I type the destination where I want it to go, and I hit enter. Fantastic, right? How easy is this? Well, it is nightmarishly easy to mess this stuff up. I'm going to intentionally make a mistake. Watch what happens when I just make one tiny typo in the copy command. So this time I'm just going to hit the up arrow key, so I just bring the command back. And what I'm going to do this time is, let's just say I accidentally typed a semicolon instead of a colon. Oh, it looks like it worked, right? Yeah, well, look really close. How many files copied? 1. Because what we just did is we took those 3 files, squished them together, and made them into one file called K without an extension. That's why whenever you copy, you really need to take the time to go over to the destination, look at everything, and make sure it's there in good order. I actually did a typo like this in a big script file that was pulling down hundreds of thousands of system logs for computers all over the country for a large enterprise. And you can't even imagine the mess I made just because of one tiny typo. So be careful with the copy/move command. Now, if I want to copy everything, you can use good old splat.splat, star.star, and it will copy everything in one big shot. Now notice there's a couple of files that we had already moved over there. Fred.txt, Mike1.jpg, and then the big mess called K. We're not going to worry about him. Let's just go ahead and say yes, 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 and everybody got over. So that's the other nice thing about the copy or move command. If it sees a file with that name already there, it's going to give you a little warning and say, do you want me to overwrite them? I could have said yes, which I did. I could say no, or I could have said yep, just for everybody by hitting A for all. So that's the copy and move command. Now what I want to do is let's do this all over again, except this time in Linux. You're going to notice it's very similar. However, there's going to be a couple of small functional differences. Yeah, let me show you. Take a look at my Linux desktop. I have got all kinds of mess on here. Look at all these files that are piling up. So one of the things I want to be able to do is to actually delete a file. So to delete a file from the command prompt within Linux, all I need to do is type rm and then the name of the file. So I'm going to delete mike1.odt. And it is gone. Now, if I want to use a wildcard, I can. Now, we don't really use a star dot star within Linux itself. We can put an asterisk after or before a letter. So for example, if I wanted to, I could do M star, and that would delete all of these files. But I need these files. I don't want to actually delete them. That command right there would work beautifully. I could also type in RM star, and that would wipe out anything that's sitting on my desktop. So you want to be careful with that. However, to copy, it works very similar to what we saw in the Windows environment. You want to start off being in the directory where you want to copy from, and here I am in the desktop, except now we use the CP command. Before we get much further, keep in mind if you want to move within a Linux environment, just replace that CP with MV, and that will move them instead of just copying them. Let's keep going. Now, what I want to do is I want to put all of these. You see I've got a folder in here called Gather, and this is actually very similar to my real desktop at my office. I put so much junk on here, I will dump them into a special folder on my desktop called Gather, and then I look at them in a very specific time and then just try to sort through them on my own. I just don't like it messing things up. So I'm going to go ahead and copy, and now this time I'm going to go ahead and copy everything. So I'm going to copy M star. Now M star. So keep in mind the capitalization still counts here, and then just the name of the folder I want to take it to. Let's see if I've done it right. Yay, my files have been copied perfectly. When you're working with files, I've given you some really powerful, some really dangerous commands right now. Understand that if you delete stuff, it is probably permanent here. It's not like using your beautiful little trash can or whatever you have within your GUI. Also, keep in mind is that you need to always go to the destination of whatever you've done to make sure the stuff got there in good order, or otherwise you can end up potentially finding a huge mess. You can do some absolutely terrifyingly powerful things to hard drives from a command line interface. And in this episode, I'm going to scare the bejinkins out of you because we've got some really cool tools. The first one I want to talk about is probably the easiest, and that's good old format. So if you take a look up on the screen here, if you look on the right-hand side, I've got disk management running, and you'll see I've got a drive put in here, and I've got it set up as the E drive. It's not formatted. I've gone ahead and partitioned it as one big E drive, but I have to format it. Over here, I've got a command prompt open. Notice that I'm running as administrator because this format command won't do this unless you are as an administrator. So I'm going to type in format and then the drive that I want to format. And now I want to do the file system. So you know what? I don't remember how to do that. So watch what I'm going to do. I'm going to type in help format. And I'm going to scroll through here. Somewhere in here is file system. There it is right at the top. So I type in /fs:, and then the one I want to do, which is going to be NTFS. Perfect, got it. Let's hit enter. Do I really want to do this? You know what? I don't, because it's going to take forever. So let's go ahead and check that help one more time. I'm hitting the up arrow key, and let's see what quick format is. /Q, now we're talking. So watch this. Just hitting my up arrow key. Look at that, I've got a couple of switches in there. So let's go ahead and hit enter. Do I really want to do this? Yes, I do. Do I want to give it a volume label? I don't want to. And I've used a tiny drive here as an example, so it happened very, very quickly. So that's format in a nutshell. You need to be really careful with this tool. If you are set up with administrative privileges, you could format your C drive and wipe out your Windows in one fell swoop. So make sure you know what you're formatting when you're using this tool. Most of the time when we're formatting from a command line is we've got a bunch of thumb drives we need to format. We got a little file that it's going to format it and put a bunch of files on there that we need, something like that. So be careful when you use it. All right, so that's format. Now the other one I want to talk about is error correction. What we're going to be taking a look at right now is the classic check disk, CHK DSK. Now we can do the same thing graphically by going into the properties of a drive and selecting error correction, but we can also do this from a command prompt. To do error correction from a command line, all you have to type in is CHK DSK, just like that. Now if you type it just by itself, it's going to go through and check the drive. And it's going to check it really good. It looks like everything's pretty good. 3, 2, 1, and it is very happy. When you type CHK DSK by itself, it just looks at the existing file table, and anything that's marked as bad, it's going to skip over that, and anything that's marked as good, it's just going to say, yeah, it's good. Well, the problem is when I do error correction, I am worried that certain blocks have gone bad since the last time I did this. I mean, that's the whole goal behind this. So running check disk by itself really isn't very helpful. What's more important to me is that it actually fixes it. Remember, check disk doesn't really fix hard drives. It just puts orange cones around bad blocks. So let's do it again, except we're going to have to add a switch. So this time I'm going to type in check disk, but this time I'm going to add the /F switch, which means actually go and fix things. And I'm going to let that run. Now you'll notice that it's saying check disk cannot run because the volume is in use by another process. And it says, you want me to run check disk next time you restart? And we always say yes. The next time I boot this system, it's going to go ahead and run the check disk and check all of my blocks to make sure that they're good. Then it'll go ahead and boot into Windows normally. So that's a pretty common way to run check disk, and the only way to do error correction from a command line. Now check disk is cool, but if you want to see some really powerful tools, you need to take a look at the tag team of System File Checker and DISM. And I never remember what all these acronyms stand for. That's a clue. They never test you what they mean on the exam either. Somebody be a pal, put it up on the there we go. Thank you very much. Anyway, the idea between System File Checker and DISM is to take a look at your system store, the backup copies of your critical system files, and to check them against the working copy. System File Checker is always your first step. You run System File Checker, and it's going to take a look at your backup store and compare your working files to those. And if it finds any bad ones, it will, well, it can look at it or it can actually fix it depending on how you run it. Generally, we run it so it'll fix. However, there are situations where even your backup store can be corrupted, and that's where DISM comes into play. So we're going to run SFC, take a look, see how that goes, and then we run DISM. You always do it in that order. Let's start with System File Checker. To run System File Checker, we just type in SFC, but that is almost completely useless. So we're going to go ahead and do what's called Scan Now. SFC is now running and looking at all my critical system files and comparing them to the backup store. If it finds any bad copies, it will literally grab one from the store and write it over in real time. This is going to take a few minutes, so I'm going to have to wait for a reboot. Now, while we're waiting, there is one other thing I want to mention. You can run Scan Now in another mode called Verify Only. And all that does is it runs the same thing, and if it finds any bad system files, it'll simply warn you that they're there. A lot of techs like to run that because they want some kind of evidence that there are problems with certain files, whereas Scan Now will simply just overwrite them and fix them. It does show up on the screen, but most people don't sit there and watch it. If you run into any kind of problem with SFC, and you've got it nice and documented so you can see it, it also stores in a log file if necessary, you can see an event viewer, the standard rule is to then run DISM. DISM is built into every copy of Windows, and all it's going to do is it will actually go online to Microsoft, find the version of Windows you're running. Remember, just because I got 10, there's a whole bunch of iterations in there, and we'll compare my system store to what is known and good over at Microsoft. So this guy kind of guards the guards. So let's go ahead and run DISM. So DISM takes a number of complex switches. So I'm just going to type these in and you can follow Mike as he goes. So we run the command, then we say check the online store with Microsoft, and then we say go ahead and look at our actual store on our drive, and then if you find any problems, fix them. If you think SFC takes a while to run, wait till you get DISM in, go online, check with Microsoft for the versions of all the critical files, and check my store against it. If this runs less than 20 minutes, you're extremely lucky, but we love it. It's an incredibly powerful tool, and it literally goes to the source to verify the quality of all of our system files. Now, the trick is you run SFC and DISM as a pair. You always run SFC scan now first. Then, if it finds any errors at all, you go ahead and run DISM. After running DISM, we assume everything's okay, but we go ahead and run SFC a second time to make sure everything's happy again. You literally cannot have bad system files unless there's some horrible corruption on your hard drive by using this methodology. It will fix everything every time, and it's absolutely amazing. Okay, now the last thing I want to do in this episode is talk about your ability to do anything you want to mass storage from a command line. We can partition, we can format, we can do anything you want using a tool called DiskPart. Talk about a scary tool. This is probably the scariest because we can completely wipe any hard drive with this. So you have been warned. Let's take a look at DiskPart. The best way to show DiskPart is to have disk management running while I run the commands. So what I'm going to do first here is I'm going to fire up DiskPart. So it's DiskPart. How's that for easy? Now this puts you into an interactive screen. Notice that we're not back at a prompt here. It's asking for demands. So there's a ton of commands in here. If you type help, you can see all the different types of commands you can run in here. So what I'm going to do in this one scenario is I'm going to take this drive right here and I'm going to partition and format it. So the first thing we always do at DiskPart is list. So right now I see I have two disks, disk 0 and disk 1. If I were to select disk 0 right now, that would be bad because that's my bootable. So I'm going to very carefully select disk 1. Okay, now I know any commands I'm about to do are going to be done on disk 1 and not disk 0. So the first thing I want to do is create a primary partition. So I'm going to create partition primary. Why does Microsoft do it backwards? Because they're Microsoft. Now you see we've now created a primary partition. By the way, I could add numbers in here if I wanted to only make it half or something like that. All right, now I want to go ahead and list. So I can see there's my only partition on here. So again, I want to select. Selecting is really important here because this is how we make sure we're not doing something to things we don't want to do things to. But Mike, there's only one partition. I know it's an old habit. I stick with it and it saves me. So I now have the partition and I want to format it. So right here, let's just type in format. And then here it's fs equals ntfs. And I want to do it quickly, so I just type in quick. And I've now actually formatted it. Now if you're looking to your right, you're like, well, you formatted it? Yeah, but I didn't give it a drive letter yet. So watch this. And now you'll see I now have an X drive right here where you can see it. This is just one example of how I can partition and format a drive using DiskPart. All I did was partition and format. You can delete partitions, you can wipe drives, you can stretch, you can do all kinds of stuff. You can mount RAID 5 partitions. This thing can handle it all, but for a lot of us, just being able to partition and format from a command line can be incredibly convenient. One of the biggest jobs we have to do from a command line is copy stuff. And I'm not talking about copying files. I'm talking about entire directory structures. I'm talking about individual partitions. When it comes to copying, standard copy commands just don't cut the mustard, and we need some super copy commands. So what I want to do in this episode is talk about 3 different types of super copy commands. 2 that are more for Windows and 1 that's for Linux. So let's start with Windows, because hey, I'm a Windows guy. The first one I want to start with is something called Xcopy. Xcopy is the original heavy lifting copying tool. It goes back to much earlier versions of Windows, and it's still with the most modern versions of Windows today. Xcopy is designed to copy not just files, but in directories, all kinds of stuff like that. It has extra features that'll allow us to do things like verify the data as it's being copied to ensure a good copy. So the best thing to do with Xcopy is just watch it in action with a little scenario I've got right here. So if we take a look over here on my C drive, you're going to see I've got a lot of DLL files that I need to get backed up someplace. So what I've done is I've got over here an X drive, and it's all formatted and ready to go, and I want to move these over in one big chunk. So to do that, I'm just going to run Xcopy. So let's go ahead and do that. So we'll do Xcopy. I don't even have to type this, but it's good habit. I'm already in the backup folder. Now you'll notice all I have to do is type in the name of the folder. I don't have to type star or anything like that. So Xcopy really thinks in terms of folders. And then I say where I want to put it. And then I could put some special extras on here. For example, /s means copy all subdirectories if any. I can put a /v, which means verify each copy as it's being copied to make sure it's a good copy. And then there's probably another 30 different switches. Here's one that's often used, /h, which means no hidden files. So we'll hit enter, and we're going to let that go to town. So if you've got to do some big heavy lifting copying, Xcopy is a great first start. However, there is another, and that tool is called RoboCopy. RoboCopy is virtually identical to Xcopy. It saves many of the same switches even. The only difference is RoboCopy is vastly improved to handle more verification and more speed. So what I want to do is go through the same scenario, except this time we're going to run it with RoboCopy. So we're going to type RoboCopy. Now, I could be in the backup folder if I wanted to and skip this step, but in this particular scenario, I'm actually in the root directory, you see, so I'll type in the name of the folder. And then I'm going to type my destination. And you're going to see a lot of these switches are similar to Xcopy. In fact, /s, copy all subdirectories, is identical to Xcopy. Another really popular one is I don't want to copy any hidden files. Now this is a different switch than the one we just saw on Xcopy, but it should be in good shape, and we hit enter. And RoboCopy is going to be up and running. Now, the cool thing about RoboCopy, and actually Xcopy does this too, is the fact that they're network aware. So let's say I've got a bunch of virtual machines on my D drive, and I want to copy it over to a shared folder on another computer. what I can do, well, let's just use robocopy as an example. With robocopy, I can type a command that looks something like this. So I can type in robocopy, where the source of my files are, and then for my destination, notice that I can actually use a UNC value. So this UNC value points to a shared folder actually on my network. Notice how I put that in quotation marks. That's pretty standard nomenclature for Windows. And this type of command will allow me to do all of my copies across a network as though it was just another drive. So these have some really big features that make them attractive when you got to do a lot of big copying. Well, that's fun, but now what I want to do is move into the big copy world of Linux. In the Linux world, the heavy lift copy champion is the good old DD command. So DD is a little bit different. DD is a bit-by-bit copier, and he lives the best life when he's copying entire partitions. So he can even be used to make image files. But before I can show you DD, we need to talk about the nomenclature of how Linux names partitions. Let's take a look right here. So what I've got here is a Linux system that has 2 drives and optical media. So this is my boot drive right here. Now if you take a look, and you have to look very closely, you see where it says /dev/SDA1? So that is the actual way that Linux recognizes these individual drives, which are each one big partition. So this one's SDA1, and then this one's SDB. And if you're actually interested, optical media is going to be like SR0. So if we know what our partitions are named, we can actually use this to use the DD in action. So let's make this one pretty simple. So what I'm going to do is copy everything from SDA to SDB. So to do that, we just type in DD and then space, and then IF is our source. So IF is going to equal /dev/SDA, and then our destination is shown as OF, and then in this case it's going to be /dev/SDB. Now if that was the only thing that DD could do, it would be amazing, but it can do a lot more. For example, instead of copying from one partition to another, we can just make an image file. So take a look at this command. Now you'll see that we have a source, but notice where the image is. In this particular example, the destination is a file called backup.img. So it's going to take everything in that partition and make a bit-by-bit image file of it that we could then use for backup. We can even make bootable media from this. Now if that was all that DD could do, that would be great, but wait, there's more. A lot of times if you really want to wipe a drive, DD can be an amazing tool. So what I want you to do is take a look at this particular command. Notice the use of the word 0 on the source. What it's doing is it's not copying from anything but a preset bunch of zeros. When you put the 0 in like that, that means just write zeros to this destination. So what we've done is we have wiped this destination partition to nothing completely but zeros. Look, if you're going to be working at the command line, odds are good you're going to have to be doing some heavy lifting when it comes to moving around folders and files. Take advantage of these powerful tools and you could make your heavy lifting life a lot easier. The CompTIA exam lists a few more command line interface commands that, while not related, are very, very important. So I kind of just threw them all together and called them advanced Windows commands. So let's go through all of these. The first one I want to talk about is shutdown. Yep, you can shut your computer down from the command line interface just by using the shutdown command. It is not common to just run shutdown by itself because it has a lot of really interesting switches. For example, /S means just shut her down, just shut it down. However, /R means go ahead and shut it down and restart the system. There's a bunch of other shutdown options. For example, you can time when you want the shutdown to take place. You can say it, well, I want everybody to log off first. So there's a lot of features to the shutdown command. But honestly, most of the time, if I'm running a shutdown, it's because I got a problem. And I'm usually doing shutdown space /S, just shut her down. So be aware that the shutdown command can really shut your system down quickly if you need it to. Now, the next one I want to talk about is actually pretty cool. And this is task list and task kill. Task list lists all of the processes that are running on your system. It'll display their name, their process ID, other information. And then task kill, as you might guess, will allow us to shut down any of these processes either by its name or by its process ID number. So let's do both. Task list is pretty easy. Just type in task list, one word, and it's going to give you a big list of all the running processes on your system right now. So what I want to do is turn something off. So let's go through and see if we can find something fun. Okay, now look right here. Do you see it says CompTIA.exe, and that's the process ID number 2704. If I scroll this up, you'll be able to see that. So it's the name of the file, process ID, who's using this type of session. Is it a service? Is it an application, which they call console? How much memory it's using? That whole idea. So let's find that one more time. Okay, so here it is, CompTIA.exe with a process ID of 2704. Now that I know that, I can now turn to task kill. Most of the time when I'm using task kill, I like to use the process ID to kill something, although you can use the name as well. So let's do a little killing. So if we got a good memory, it's CompTIA.exe with a process ID of 2704. So I can type in task kill. Now this is a good place to use help because it shows some fairly interesting options. First of all, look at here. It says task kill with the process ID, and then you just type in the number. However, if you want to, you can actually, here they have an example of notepad.exe where I can actually use IM. So let's just go ahead and turn this off using process ID. And it's dead, Jim. A lot of times when you're running scripts in particular, these types of tools, especially if you're trying to turn something off to do an installation in a script or something like that, can be absolutely handy. Okay, the third pair I want to talk about is something called GPU update and GP result. In order to make sure we understand what these guys do, what I want to talk about is something called a group policy. Here I've got my own little computer that I'm running every day, and he has some local security policies set up. In particular, I have a local policy that says we don't care about complex passwords, so no complex passwords for us. However, this computer is a member of a domain, and he is connected to a domain controller, which is controlling the domain that I'm a member of. Inside this domain controller, they have their own security policy, which are called group policies. It's really just about exactly the same thing, except that these have much more complex policies. Pretty much everything I've got, they have there plus a lot more. And they have set up a policy that says we require complex passwords. The problem is there's no active way. When someone makes a change up here, there is no active way to propagate that down to all the individual systems quickly. So we've got to sit there and run something over here that says, have you made any changes, sir? And then it will update our policy on our machine. If you're on a domain and you have a group policy that is different than your local security policy, well, tough bananas, it will override it. And this is where these tools come into play. We're going to use GPU update to query our domain controller and see if anything's been changed, and then we see GP result to see what those changes are. So let's start running them. So first we'll just run GPU update, and he's going to go out to the server and he's just updating his policy. It's pretty straightforward, although it can take a moment before we actually get the answer we want. So let's see what happens. Yeah, fantastic. Now the problem here is that it said it's successful, but how do you know that? And that's where you use GP result. Now I need to warn you, the output from GP result is messy. You're not going to be quizzed on how to interpret everything, but you should have an overall look and feel where if you see a question on the exam that says, what output did this? You should be able to recognize it as GP result. It's pretty obvious looking output. So I'm going to run GP result with that /R option. R is actually the smallest output you can generate. All right, so this is the end result of this. The important one is right here. I'm just doing this as a demonstration, so unfortunately I don't have anything updated on my group policy server to make a change here. But here's where we would see the results and have verification that, for example, it would say complex password applied would show up right here. You don't run GPU update or GP result just for fun. It's not a maintenance tool. You're running it because somebody on high has said, we have gone ahead and made some policy changes and we need it to get down to all the individual client systems. In fact, we usually don't even run them manually. What's happening is we embed these into scripts so that they're like, okay, we got everything updated. Be sure the scripts run on everybody's computer at 3 a.m. And then we hit a button and they all run and we've got our job and we can go home at 5 o'clock that afternoon. So these are some very interesting tools and you will see them both on the exam and the real world. Take some time, particularly with shutdown. It can be an incredibly handy tool. Well, you can't have an episode covering advanced Windows commands without doing the same thing for my friends over at Linux. And by the way, pretty much all these commands work just fine on a Mac as well. So in this episode, I want to cover a few very assorted advanced commands that you'll not only see on the exam, but you'll use time and time again within the Linux environment. Let's start off with a big one, shutdown. The shutdown command does as it implies. It shuts down your computer. Now if you type shutdown by itself, I get 1 minute. And if I type shutdown -C, that will cancel the shutdown. If you want to shut down and reboot, I'm using the up arrow key, I can just type it like this, shutdown space -R, and that'll shut it down in 1 minute and it'll actually reboot the computer. And if you're really in a hurry, you can type shutdown now. I would like to continue teaching this video, so I am not going to hit enter because if I hit enter on shutdown now, it will shut down and we'll be done. So let me backspace that out a little bit, clear up the screen, and let's talk about our next command. One of the big challenges for decades with the Linux environment was getting applications. Back in the scary old days, you didn't even get executable programs. You just got source code and you had to run onboard compilers and compile it and go through painful installations, which meant updating text files. And you kids don't know how good you got it. Because after a while, certain distributions began to develop, in essence, stores where you could grab certain applications, download them, they would automatically install themselves. It was a pretty thing. Now we basically have two camps here. We have the Debian camp and we have the Red Hat camp. Now this is interesting because some of the objectives on the A+ actually say apt-get. That means it's Debian. So that's why I've been using Ubuntu in these episodes because they actually give us some clues that they're more into Ubuntu than any of these other distributions. So apt-get is a great example. apt-get is a repository of just about any program you could think of that can do almost anything you want. If I want to get a program, all I have to do is be at a command line in a Debian-based Linux and run this particular command. So I'm in Ubuntu, which is a Debian-based Linux, and I can go ahead and run this. Let me show you how apt-get works. Everything with apt-get starts with, got to use sudo, apt-get update. What's happening right now is my onboard repository is being updated so it knows the latest versions of thousands of different applications. Whenever you install any kind of Ubuntu, any kind of Debian Linux, you're going to run through this process. And I've run it recently and we take a look, it's already pretty much done, so we're looking good. What I've done is I've updated my repository. So it's amazing. Let's say I want to use a program called, it's an editor called Joe. So I'm on my system and I type in Joe because I want to run it. And look what happens. It'll actually say it's not found, but it can be installed. Now I need you to look really carefully here. It says sudo apt, not apt-get. The reality is that apt-get is fairly deprecated at this point. We use apt instead of apt-get. However, apt-get will still work 99% of the time, and that's the actual objective. CompTIA, get up to speed a little bit here, will ya? So we'll do this with apt-get for CompTIA's sake, but normally you just run the apt command. They work almost exactly the same way. So what I want to do now is I want to install a program. I want to install Joe. It's actually a really good text editor. So I'm going to do sudo apt-get install Joe. And what's happening here is the program is being downloaded from on high and it comes down into my system and it is, it's still installing and it will be installed. I'll be able to run this program. It is incredibly convenient. Now you'd think to yourself, well, Mike, how did you know the name of the program was Joe? Well, these are famous programs. If I wanted to, pretty much all of these Ubuntus have some kind of store where it's done in the exact same way, except it's done graphically. The important thing is I can do this from a command line using apt-get. Really apt. Okay. The other thing we run into is that we often have to upgrade our software. And that being the case, we still use apt-get. This time what we're going to do, it's all installed. Cool. Let me clear that screen. So this time we're going to run apt-get. Now I can run upgrade by itself and it will upgrade every piece of software on my system. In this case I just want to do it for Joe. And it will go ahead and upgrade just that one particular application. So if you want to upgrade everything on your system, just do apt-get upgrade and it will update everything on your system. The last thing that's going to happen is sometimes you want to delete a program, and apt-get works fine for that just as well. In this case, we're going to use the remove. All right, so let's type in sudo apt-get remove Joe. Do I want to continue? Yes. And now Joe is being uninstalled. Again, you can do all this stuff through most Linux front ends, but if you need to do it from a command line, apt-get, or really apt, is the best tool around. All right. The next thing I want to talk about is something that really happens a lot within Linux, and that is I'm always wanting to check all of my processes. Now, in other episodes, we talk about process IDs in a Windows environment, but remember, these are all running on Intel processors, so everybody still has processes, whether I'm running on Linux or Windows or Mac, and if you want to have a look at all your different processes, and especially if you want to turn off a process, you need to be comfortable with the tool called PS. So running PS by itself is kind of boring because all it's going to show me are any processes that are tied to the user that I'm currently logged in as. So right now I'm logged in as Mike, and pretty much all you're going to see is the bash shell that I'm in right now and then the PS program itself. But if you look at it, you do get some good information. In particular, you get the process IDs right here and the name of the program. So this by itself is a little bit dull. The PS command comes with lots and lots of amazing flags, but probably the most famous one is PS aux, A-U-X. A lot of people do it AXU, it doesn't matter, which basically says, I want to see all the processes. I don't care if it's coming from the system or from other users, and I want a lot of detail. So watch what happens when I type PS aux. Woof, okay, now we got a mess. But it's actually really good information. I'm going to have to scroll up a little bit here. Let's get up to the top. Here we go. So you can see the process ID. You can tell what kind of user it is. Root is the system itself. I've got like CPU usage. This is just a snapshot at this given moment. TTY means, what kind of terminal, what kind of monitor it's using. So what's really interesting to us more than anything else is what command is actually running it. You can see all these here. And when did they actually start? So between the command itself and the process ID, we can do a lot of really cool things. So for example, if I want to, I'm going to go ahead and start up a program. So let me go in here, and I'm going to start up this little word processing program. So let me minimize that, but we know we've got a word processing program running now. And let's go ahead and run PS aux one more time. So what I can type is PS aux, and now I'm going to do something called a pipe. Do you see that? That's a little pipe. What we're going to do with a pipe is it basically says, look, I know normally you would just put your output on the screen, but instead of doing that, I want you to funnel your output to whatever I type in after the pipe. And this is classically how we use grep. So I'm going to type in grep, and then whatever string I'm interested in looking for. So in this case, I'm looking for Libre. So it's going to run the PS aux. It's going to take all that output and hand it to grep. Grep is then going to look through that output, and any line, remember grep works only with text files, any line that contains that string, he's going to bring it out onto the terminal so I can see it. So let's watch the magic, and here we go. So what's happened here is I now see 1, 2, 3 lines. I have 3 different process IDs. So this isn't uncommon. LibreOffice is complicated. It's got 3 processes, no big deal. So what I want to do now, and this is a big thing we do with PS aux, let's do a little more killing. So to do that, we're going to kill one of these processes using, guess what? It's called kill. So watch. So I'm going to type KILL, and then I just type in the process ID. So 1, 3, 4, 8, 2. And we hit enter, and we don't get any output. That's because it's dead. So I'm going to go ahead and run PS aux one more time. And now you'll see it actually killed 2 of the 3 processes. That's because there was a dependency in there, and that's okay that it went ahead and killed 2 of them. I wish it had killed all 3. So that's a kind of a rough feel of some of the programs that you're going to be seeing on the A+ exam that are within Linux. However, there is one more I want to talk about. And CompTIA, you guys really, really need to get this off of the competencies. We use text editors like crazy when we're working within a Linux environment. And that's a good thing. Luckily for us, there are thousands of text editors that work at a command line. I have graphical text editors. They're amazing. There's zillions of them out there. And yet CompTIA, for some reason, continues to talk about literally the oldest text editor ever invented, VI. So let me give you at least a quick peek at this absolute disaster of a text editor. To run VI, you just type VI, and I'm going to give it a file name called junk. And what's happened now is I am in a text editor, but don't you dare think about typing on any letters right now. You have to hit the letter I, which will then put you into a insert mode, and then you can start typing. Now that seems okay, right? You can even hit enter and you can get a carriage return. But other than that, you're in big trouble. The way you manipulate this text editor dates from the 70s. In fact, let me show you. I'm going to put a little piece of paper on the screen. Here are some of the commands that you have to do to manipulate stuff in VI. So do you see all these? This is how you move your cursor around within the VI text editor. I'm not sure why people still want to support this, but it's still out there. Listen, the VI is on the A+ exam. I'm telling you right now that there are 1,000 better text editors. There are programmers out there, and they probably don't have much social life, who are really, really good at this. God bless them. For the exam, make sure you're aware that VI is a text editor, and also make sure you're aware that Mike Myers absolutely hates it. You can do a lot with users and permissions from a command line. So in this episode, what I want to do is concentrate first on dealing with permissions. And then I want to talk about things like changing password and ownership. So first of all, let's take a look at changing NTFS permissions using a program called iCackles. That's fun to say, isn't it? Now if you take a look right here on my D drive, you'll see I've got a folder called Timmy. And what I want to do is I want to give the Mike user account full control over that Timmy folder. So to do that, we just type in iCackles and then the folder or file I want to apply it to, and then I want to grant to the user Mike full control. So let's hit enter. Ta-da! iCackles is wildly complicated, and interestingly enough, it's not on the A+ exam. So you're sitting there going, well, Mike, why did you just show me that? Well, because you need to know it as a tech. What is on the exam is changing permissions within a Linux environment using the Chmod program. Now, before I show you Chmod, let's take a little quick peek at Linux permissions. So, poof, I'm going to turn this into a Linux box. All right, so here I am in Linux. Now, what I'm going to do is type ls, but I'm going to use the -L switch on there. And you'll notice that I have here 2 files and 1 directory. Actually, you can see them right here as well. On the far left, you're seeing the D stands for directory, so we're going to ignore that for right now. Notice gather is a folder, so it has that little D on the far left. It's the other 2 I'm interested in. So ignoring that first dash, it is read, write, and execute for the user, for the group, and then for other or everyone. So every file and folder has this RWX, RWX, RWX thing going. If you see a dash instead of one of those letters, it simply means that permission's turned off. So let's go ahead and take a little bit of math to see how we can manipulate these different permissions. I've got this file called Fred. And if we type ls-l on the left-hand side, we're going to see RWX, read, write, and execute for the user, read, write, and execute for the group, and read, write, and execute for other. So what I'm going to do is let's have a little fun. So underneath this R, I want you to put the number 4. Underneath this W, I want you to put the number 2. And underneath the X, I want you to put the number 1. And go ahead and do this for the other 2 groups of 3. Okay, so what's 4 plus 2 plus 1? It's 7. What's 4 plus 2 plus 1? It's 7, and it's 7. So if I want to change the permissions on the Fred folder to be read, write, and execute for the user, read, write, and execute for the group, read, write, and execute for everybody else, I'll type a command like this. Chmod, isn't that a great name? And then 777, and then the name of the file, which will be Fred. By doing this, I now have granted the actual user read, write, and execute permission, the group that he's a member of, read, write, and execute permission, and in fact, anybody who accesses this file will have read, write, and execute permission. That's fun. Let's do it again. So now I've got a situation where it's just like a document, and so it's not executable. So let's get rid of these ones. And what we have is I want the user to be able to read and write on it. I want my group to be able to read and write, but everybody else, they only get to read it. So let's just do the math. 6, 6, 4. So in order to set this up, I run the chmod command, 6, 6, 4, and then the name of my file, I hit enter, and I've changed the permissions. So what I want to do right now is I want to adjust my Fred file on my desktop so that anybody in my group can read and write to it. Right now it's just set to write. So let's check this out. So let's take a look. Here we see the Fred file right here. First of all, the owner, that's me, I can read and write to it, but everybody else can only read it. Do you see that? So let's change that right now. Easy enough. We're going to type in chmod 6 6 4 and then Fred, and we hit enter, and nothing happens, which is good. But if I type ls-l, then you're going to have to look very carefully, but you'll notice that now my group has write permissions. Chmod is a great tool. However, if you want to take advantage of it, you need to actually have ownership of that particular file or folder. So what I want to do next is show you how you can take control of any individual file or folder within the Linux environment using something called chown. So let's do a quick chown. So going to my previous example, we'll see that I have a file called Fred in here. Now if you look right now, the owner user is Mike and the group is Mike. So I'm going to chown that. So I'm going to type chown and I'm going to change it from Mike to Timmy. And remember, it's Fred that I want to do this to. Oh, I've got a problem. The problem is I didn't use sudo. So I'm going to just type in sudo chown and I'm giving Fred to Timmy. And now if I type in ls, we'll see that the user owner went from Mike to the Timmy account. One more bit of fun and we'll be done, and that is, how do you change a password in a Linux environment? Now, of course, we can do these through graphical tools, but to do it from a command line, we just type in password. So the important thing about this is first be logged in as the account that you're interested in changing the password for. I'm currently logged in as Mike, so I'm going to go ahead and change the password. So we're going to do sudo, enter the new password, retype it, and I successfully updated the password. All right, so the big takeaway from here is that we've got 3 commands I really want you to be aware of. Number 1 is chmod, and that's changing file permissions in a Linux environment. Chown, to change the ownership. And last, and certainly not least, passwd, to change your password. If you asked me if there was one way that I could separate the real super text from the regular run-of-the-mill text, it would be their ability to handle scripting. Scripting is a critical component of anybody who's working on computers today, and that's what we're going to be doing in this episode. So first of all, well, what is scripting? What you need to do is get yourself to a command line and recognize that while the command line is powerful, we often find ourselves doing the same tasks day in and day out. For example, I got a bunch of log files I need to delete. So if you look at this folder, you'll see I've got all of these old log files from way back when just sitting here, and I got to get rid of them. Now, what I can do is I could just go into a command prompt, head over to that folder, and I could just delete them from here. But I got to do this all the time, so I want to come up with a clever way to automate these boring tasks. And the tool we're going to use, at least for this first job, is what's known as a batch file. A batch file is nothing more than a text file. It's just a text file, and you write it out in a text editor. I like to use Notepad when I'm on a Windows system, and really all you're doing is each line typing in a series of commands, just as though you were at a command prompt. You typed each one and hit enter. Let's go ahead and whip up our first batch file. So I'm going to open up Notepad. And let's go ahead and start typing. Remember, our job here is to delete those log files. So first of all, I want to get into that folder. So I'm going to have to type in, here we go, cd space c colon backslash users backslash Michael M backslash desktop backslash logs. So this is going to get me into that folder, and then I want to delete all the log files, so I type del star.log. Now, once I've typed all this in, what I need to do is save it with the extension BAT. This particular program, Notepad, wants me to save it with a TXT. We're not going to let them get away with that. So just by changing this to *.*, it will now save with the BAT extension. Now take a look at this. You'll actually notice that the icon's a little bit different. I've actually turned on my file extensions so you can see these, but even if it wasn't, you can still see it's made a different type of file. So I'm going to go ahead and run this. Nothing happened, right? Well, yeah, it did. It got rid of all of those log files. Well, this is great for me, but what if I wanted to give my buddy Shannon this same batch file? In that case, it's not going to do her any good because it CDs into my home directories. So what can we do to get around that? Part of the answer is through what we call an environment variable. So I'm going to open up a command prompt and just type set. What you're looking at here are environment variables. Environment variables are certain phrases that point to certain places or things that work for anything throughout the operating system. Like, for example, here's something called home path. Home path right now, because I'm logged in as Michael M, is users/Michael M. However, if my buddy Shannon logs in, that will change, and the environment variable for home path will be changed to whatever Shannon's folder is. So what we're going to do is we're going to rewrite that batch file now, except I'm going to change the path a little bit so that we can get to anybody's folder. Doesn't matter who's logged in. So you got to be careful here. You'll see that right now this is, if we double click on it, it's just going to run. So I'm going to right click on it and hit edit. So what we're going to take out is this part right here. And watch how I replace this. I'm going to use %, home path, %. What that's going to do is whoever's home path is active when they're logged in, it will replace it with their path and it'll work for whoever is logging in at that moment. Batch files are fantastic and people have been using them for 40 years now. Goodness, I'm old. Anyway, the downside to batch files is that, well, they're not very powerful. Like, for example, I want to be able to delete log files, but I only want to delete log files that are, say, 15 days or more old. In that case, batch files are going to have a little trouble. I'm sure there's somebody out there right now going, oh, Mike, you can do it this way. No, 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 no. There are more elegant ways to do things. And Microsoft knew that, and many years ago came out with an alternative shell called PowerShell. So let me give you a quick tour of PowerShell. So on my version of Windows, I just right-click and select Windows PowerShell. And you'll see I get a nice pretty screen. Now don't let the color fool you. Everything still works. Look, I can type dir. I can type cd / get to the root directory. I can clear the screen. So the commands you've learned in other episodes still work perfectly well here. However, PowerShell has some pretty amazing features. One of the things I want to show you is I've got a PowerShell pretty much already made. And you'll see it's right here. It's called PowerShell.ps1. And what I'm going to do is I'm just going to right-click on this and open it. So it just opens in a notepad. So wow, what do we got here? This is called get-child item. What you're looking at is that PowerShell really knows Windows. With PowerShell, you can query Active Directory. You can update your registry. You can do all kinds of very, very powerful stuff through these little things called commandlets. If you really want to see commandlets, I get to show you something very cool called the PowerShell Integrated Scripting Environment. So watch what we do this time. Here I'm just going to right-click on it again, except this time I'm going to click on Edit. What you're looking at is an environment that's designed to help people write these. Keep in mind that a PowerShell script is just a text file. And what you're looking at is an incredibly powerful text editor that helps you build these things. PowerShell comes with tens of thousands of discrete little commandlets. Nobody's got this stuff memorized, but this helps you along. So you can look here on the right, and it just shows you gazillions of all kinds of different commandlets for all kinds of different things. And no, I don't know them, but there's tons of them in there. What's also nice, if you take a look across the screen here, you'll see how the different colors show up. That's basically the integrated scripting environment letting you know that everything looks good. If it had a problem, it would be highlighted right now. This is called the integrated scripting environment. PowerShell is incredibly powerful. If there's something you need to do to Windows, there's probably a PowerShell commandlet to help you do it. If you want to add users, change network settings, I literally can't tell you all the powerful things that PowerShell can do. However, this isn't just a Windows world. If you really want to talk about powerful shells, we have to talk about Linux, and in particular, the bash shell. Now, what I'm going to do is I actually have an example bash shell to show you right now, and I'm going to pull it up in Windows. Sorry, I'm a Windows guy. So if you take a look, these bash scripts end with the extension sh. So I'm just going to double click on this, and I want you to take a close look. First of all, do you see these little bangs, the number signs? Those are just remarks or comments. They're put in there for people who are looking at this to get an idea of why all this stuff is here. Echo just means put something up on the screen. For example, this goes echo blank line, echo installing repositories, echo blank line. Now here are the actual commands. This is very similar to what we'd see in a batch file. Now in other episodes we talk about sudo commands and using apt-get and such, so these should look familiar to you. So you have all of this stuff, and it's really just this one line that we have to deal with. And it just keeps going on and on like this, scrolling through with a bunch of commands, obviously installing something really, really big. Scripting files are absolutely critical to be a good tech today. It's going to be on the A+, sure, but you should know these things. Make sure you're comfortable with what is a batch file, what is a PowerShell script, and what is a bash file. In other episodes, we talk about stuff like processes and services and applications and really just programs. What we're talking about is stuff that is running on your computer, doing whatever we want them to do. Without programs, our computers are nothing. We have to have programs that are doing stuff. But I often wonder, do people really know what a program is? So I've got a bunch of programs sitting on my screen right here. Let's take a look. What you're looking at is a bunch of files that have the extension exe. These are executable files. They are preset lists of commands that are designed to talk to Windows and to your CPU. So where do these exe files come from? Well, they come from programmers. There are people who know how to write these types of code so that they can get work done. The problem we have here is that these exe files are what we call compiled code. What will happen is somebody will write some code in a kind of a languagey looking thing. You've probably seen programming if statements and do loops and stuff like that. But then they have to go through a process called compiling. Let me show you what I mean. There are lots of languages that we write programs in. Right now they have names like C or C#. And what you do is you write code, and they're really just text files, and they write the code to do whatever you want them to do. The trick is that they don't run like this. You run them through another program called a compiler, and the compiler will then generate these exe files for us. Executable files are fantastic, but there's one downside to them, and that is you have different compilers for different operating systems and different CPUs. So if you write a word processing program, say, I don't know, Microsoft Word, you have to compile one version for a Windows environment, then you compile another version for the Mac environment. So they work great, but you're always going to be very operating system and CPU specific. So that's great if you have standalone programs that you install on individual computers. But what if things get a little bit more broad? Like, for example, the internet itself. In that case, we need something known as an interpreted program. Interpreted programs have names like Visual Basic and Python and JavaScript. Now, the idea behind these is that we still write these programs out in some kind of programming language, but something very different happens. With these, built into every different operating system is what we call an interpreter. So these interpreters work in Windows, and they're going to work on a Mac, they work in Linux. Maybe they may not work for all these programs and all of these different operating systems, but most of the time they do. And the cool part is that in order to run this program, it never is turned into an exe. We simply take the code, run it through the interpreter, and it comes out and does whatever it needs to do. Interpreted code has some real benefits. We can write one piece of code, and as long as we're not asking that piece of code to do something very Mac or very Windows specific, we can take one piece of code and it'll pretty much run on any operating system we want. The trick is that the operating systems have to have the right interpreters in them. So really what I want to talk about is the different type of interpretive languages that we're going to see both on the A+ and in the real world. And also keep in mind, we often use the term scripting language interchangeably with the concept of something that's just interpreted. So I'm going to use scripting language if that's okay. One of my favorites to go to first is good old Visual Basic. It's been around a long time and, well, Mike knows it pretty good. So I've got this little file right here, and his name is test.vbs. That's a Visual Basic script, and it's really just a text file. So let's go ahead and edit it. So you can see it's just a text file. I've got it open up in Notepad. First of all, you can see it has some commentary remarks there. In this language, it's just a little apostrophe. Now, what I want you to look at is right here. Do you see where it says dim? What we're talking about here are variables. Variables are values that can change based on how we manipulate them. So you can have different types of variables. In this particular one, you'll see it just says dimension num1, num2, and num3. Now, because it says num, you'll go, oh, Mike, that means it's a number. Well, it may be or it may not be. What we're looking at in most of these interpreted languages is that they're pretty flexible. In certain languages, you have to be very specific when you make a variable. For example, you have to say, this variable will be an integer, or this variable will be a string value. A string value basically means anything you want to put in there. By setting up the different types of variable types, we can use less memory and we can have better controls on it. For example, if we dimension a particular variable as a string, we're going to try not to add them together. That makes sense. Whereas if I put them up as integers, then we may want to go ahead and add them together. Different languages have different ways to handle this, but be aware that we declare variables and we declare them as a type. However, in a lot of languages, you just declare them like we see here in Visual Basic, and they're pretty much all going to be strings, even though it says number. In fact, that's going to be a problem as we write this code. Let's take a look. So it declares these variables, and then it's going to give num1, num2, and num3 a value. And it says, please enter the first number, second number, and third number. We'll see how this works in just a minute. And then it's going to do a little check. For example, if these values are numeric, then, and this is a conditional, if then right here, and here's some more commentary, let us know what's happening. And then it'll say, put an output saying you've entered these three numbers. Now, the problem here is that these have been declared as basically they're strings because it doesn't say anything up there. So it has to say this value. CDBL in Visual Basic means I don't care what this is, turn it into a number. So if CDBL of num2 is greater than CDBL of the current largest number, then the largest number is now num2. Get the idea? And then when the third number comes along, do it again. So basically this piece of code is going to ask us to enter 3 numbers, and then it's going to tell us which one's the largest one. So it's fun to look at the code, but let's actually run it. That's even more fun. So this is an input box. So I'm going to put the number 2. Then I'm going to put the number 55. Then I'm going to put the number 16. And it says you have entered these 3 numbers, and the largest number is 55. Pretty cool how Visual Basic gives us the opportunity to work with graphical boxes and such. In fact, pretty much all scripting languages do. You can also run them just fine from a command line. It's just a matter of personal choice more than anything else. All right, now what I want to do now is move on to something a little bit more, what's the word I'm looking for? Widely used. Visual Basic is fantastic, nothing wrong with it at all. However, it's pretty much very specific to Windows. You're not going to find an interpreter for Visual Basic on a Mac. I know there probably is one, but they're not common. So let's move on to something that more people will run into, and that is Python. Python works great in a Linux environment, and I've even actually got a little program up and running ready to go. And it's a game, so let's play tic-tac-toe. So this is Python in action. He's actually just up and running a little program, and I can go ahead and play the game, and it won't even tell me if I win. Okay, that's a cruddy program, but it is written in Python. Python is very popular. It runs on every operating system. If there is one that it doesn't, I'm not aware of it. Python is really popular because it's easy to read. A lot of these scripting languages could be a bit challenging to understand and actually look at. But Python's known for being easy to read, easy to make variables. People really, really like it. And you're going to see it a lot, particularly in a Linux environment. Now, the other issue we come into is that most of the time when you go to a web page these days, you're not going to a static web page. You're going to what we call a web application. And the tool that is built into every browser is called JavaScript. JavaScript is the tool if you want to write something on what we call client-side applications. Let's take a quick second to make sure we understand what a client-side application is. So here's my web browser that's running on my local computer. And remember, we go to a web server to get that web page. Now, if we want something to run on it, we can send down the code to the individual web browsers and then run the code on the client itself. Those are called client-side. Now, for the record, there is another way to do stuff. And you can run programs up on the server. The server will then generate a static HTTP page and pass it down to you. So that's what we call server-side. We use server-side tools like if we're trying to access a database or something on a big server, we'll grab the information we want and then just pass it down to the clients. However, for client-side stuff, the only thing in town really is JavaScript. Let me show you how he runs. So I'm over on Mozilla.org. They write lots of great code. And this is a little game. It's actually a breakout game, but I want you to look at the raw JavaScript first of all. So look at all these variables that are being declared, lots and lots of them. Then we have these for statements. A for statement is a conditional loop, which basically says, for as long as this variable is doing something, just keep repeating itself over and over again. And then here's some if statements, which is a great example of conditional. If this, then that, else go that way. So then we have all these functions. Functions are nothing more than chunks of code that are run over and over again. So instead of writing them a zillion times, we just put them in one little function. So this is the actual, all the code itself. On the HTML page that comes down, we just put a little tiny piece of information in there. But the result of all this on a browser is actually pretty impressive. So we actually get a little breakout game. All of this code is being interpreted real time here on my web browser. And that, my friends, is JavaScript. Programs like Visual Basic, oh, by the way, Visual Basic has a VVS extension, and Python has a .py extension, and JavaScript, which has a .js extension on its files, are very robust programs. You can write pretty much anything you want in them. It's just important to remember that things like Visual Basic are going to be living in a Windows world. Python is going to be just about anywhere, but it tends to be more standalone code written for individual machines. But if you're talking about client-side code, your only real choice is today JavaScript.